first look at mirror images of or reflections of the cos graph. If you look now here at cos of minus theta, on the first graph, again, it's the mother graph, but when I try to draw cos of minus theta, I see I get exactly the same graph, although it happens at different positions. For instance, this point F happens when I had the minus 90 on the green graph. If I multiply by minus, I will get the plus 90 and I will get a dot there. But in the end, it looks exactly the same. So if I look at the graph of G, the red graph, I see I have a period of 360 degrees. The amplitude is still exactly the same one. The roots are the same, exactly the same. They are at B, at D, at F, at H, and at many more. And the general formula will be exactly the same as that for the cos. And for cos, we have theta equal to 90 degrees plus k times 180 degrees. Because if I make k equal to 0, I will get the first one. If I add 180, I will get there. If I add another one, I get there. And the same here. If I start with 90 degrees and I add, then I'll get there, etc., etc. So it's the same as the original function. The extremes are exactly the same. They are y equal to plus 1 and y equal to minus 1, both of them. So and the minima, they occur at exactly the same points. So you can have a look at the formulas there. So we can also write this as a 2k plus 1, whatever, to make it easier for us to substitute a simpler formula. So, but what is important here, the minima, we can see they are at C and at G. And the maxima are at A and E and I. And we have the same values, the same coordinates, except that it happens at a different stage. So in this case, we see that cos of minus theta is equal to cos of plus theta. In this case, it's a reflection about the y-axis. So it's mirrored in the y-axis. So if you put a mirror on the y-axis, you will see exactly what happens on the other side. If we move the minus sign now to the front, so in actual fact it's a minus 1 coefficient in front of a cos theta. That means that each and every y value must be multiplied by minus 1. So if I take this value here, if I take plus 1 there and I multiply by minus, I will get minus 1. If I take minus 1 multiply, I will get plus 1. So if I take that one multiply by minus 1, I will get a negative value. If I take this one multiply by minus, I will get it on top there, and that one will go down. So in this case, we still have a period of 360 degrees. We still have an amplitude of that. We have exactly same roots. So the roots are still at B and D and F and H, etc. And the general form is still theta equal to 90 degrees plus K times 180 degrees, just like before. Exactly the same. The extremes are still y equal to minus 1 and y equal to plus 1. It's just they occurs at different positions. So if I write down the coordinates of the minima, the point G of the original function will be, G will be the point 180 degrees minus 1. But M, and that was a minimum. But now M is the point 180 degrees plus 1, which is now a maximum. So all the minimums becomes maximums and all the maximums becomes minimums. So they are swapped. Exactly the same as before, but they swap. So in this case, we have a mirror about the x-axis, or a reflection about the x-axis, or a mirror in the x-axis. On this page, we have now a summary of what we did before. First of all, we see that g of theta, which is cos of minus theta, is exactly the same as the original function, and we see it was a reflection about the y-axis, or it was mirrored in the y-axis. We also see, because the green function is exactly the same as the red function, we have an identity. Cos of minus theta is equal to cos of plus theta. And then if we look at the other graph where we have negative cos theta, then the only thing that happened is we have a reflection about the x-axis, or we are mirrored in the x-axis. So all the plus values become minus values, and all the minus values become plus values.